Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have this simple integral that I would like us to look at. It's the integral of x to the power 3 e to the power x squared dx. Now how we approach it is look at the power of e is x squared, and we can obtain x squared from here. So we split this into x squared times x as follows. Taking us to page 1. Basically we are saying the integral of x cubed e to the power x squared dx should be expressed as follows: the integral of x squared e to the power x squared x dx. Notice that this and that, when you multiply them, they will give you x cubed. But now we have x squared as a power of e, so we're going to let t be equal to x squared. So let t be equal to x squared, and so dt dx, you agree with me that we use power rule here, 2x. Multiply and reduce power by 1, power rule. At this point, I'm going to multiply both sides by dx. I'm going to get dt is equal to 2x dx. But if I look at this part here, I have x dx. So I have to divide by 2 both sides. So dt over 2 is equal to x dx. Fantastic. Now, this integral therefore can be transformed as follows. The integral of where there is x squared, I'm going to put t e to the power t, and where I see x dx, I must put dt over 2. So times dt all over 2. And remember, 2 is dividing, so you can take it out because it's a constant. So we have 1 over 2, the integral of t e to the power t dt. Right, now from here we proceed. As you would imagine, we are going to have to use integration by parts now as follows. So moving forward, let me move this one down. All right, so taking us to page 2. So now I'm going to say my focus is on integral of t e to the power t dt. So I'm going to let, remember we have half outside, so I'm going to let u be equal to t. Remember, integration by parts, we have to say dv be equal to what is remaining there, which is e to the power t dt. E to the power t dt. Now we differentiate here with respect to t. So on the left we have du dt. On the right we have the derivative with respect to t of t. You'll agree with me that du dt is just equal to 1. Multiply by dt both sides, du is equal to dt. On the other side, integrate both sides. You'll agree with me that you just have v is equal to e to the power t. Now, integration by parts formula, the integral of u dv is equal to uv minus the integral of v du. Notice u dv is basically t e to the power t dt, which is basically that integral you have there. So we're going to say this here is the same as the integral of t e to the power t dt must be equal to, what is uv? Well, u is t, v is e to the power t. So t e to the power t minus the integral of, what is v? E to the power t. E to the power t. What is du? Is dt from here. And so what do we have here? It's t e to the power t. The integral of e to the power t with respect to t, you'll agree with me, it's just e to the power t. But this is not over, because remember we have half outside there. So we're going to say therefore half of the integral of t e to the power t dt must be equal to half of this. Must be equal to half of this one here, t e to the power t minus e to the power t, and then we must say plus c now, because this is an indefinite integral. So we have to distribute half. If I move backwards here, I'm going to say that is equal to half of t e to the power t minus half of e to the power t plus c. Our final step would be to revert to our original variable, which is x, and the connection between t and x is that t is equal to x squared. So where there's t, I must put x squared, and then I'm done with my integral. So let's conclude then. On page 3, we're going to say, therefore, the integral of x cubed e to the power x squared dx must be equal to, now remember what I said. What I said is, where there's t, I must put my original variable, and the connection is that, as you can see here, t is equal to x squared. So this solution, therefore, this solution which you can see here, simplifies to half x squared. Remember, t is equal to x squared, e to the power x squared minus half e to the power x squared, and then I have to say plus c. If you're interested, you can factorize here. You can see the common factor is actually half e to the power x squared as follows. Not necessary, but sometimes one would need to do that. Half e to the power x squared. Taking out half e to the power x squared here, you have x squared. This in there, you just have minus 1. And then you have plus c. So either you leave it in this form or that form. This is just perfect. Not a problem at all. All right, tell me what you think about this integral. Just to remind you that the integral of interest that we've been looking at in this video is this one. We simply had to split this into x squared times x, and then went on to use t substitution, which is another form of u substitution, and then we had to go to integration by parts to complete this integral. All right, I'll see you in the next one.